Alright, we're going to do a little video today where I'm basically just going to talk about a simple way to generate an isometric map in Java, and it's going to be one that's not all random, but this is going to be a pretty cool way to do it because we're going to add some trees to it. We're also going to add some little cliffs, I guess, some raised areas so you can see sort of how height might work with an isometric map. So I've already set up the project a little bit, but I've stripped most of the implementation out of it. That way this video doesn't get too long, but also we skip some of the boring boilerplate stuff, right? And I don't have to type it all out. So anyways, whenever you make a Libgdx project, and I hope that anyone who comes into these tutorial series has at least experimented with Libgdx a little bit. Really, I don't feel the need to go over the basics of it, like setting up a project, because there's so many better resources online for that already. You could go to Libgdx documentation or something, and they would teach you probably a little bit better than I could in one video how to set up a project, what the basic flow of things is in Libgdx. But all I did here, so when you generate a Libgdx project, you're going to get this main game class here, which I've made extend game. I've also added a sprite batch, or well, I didn't add a sprite batch, but I made the sprite batch private. Then I created a class called game screen, which I made extend screen adapter. This is how I normally work. And then I set it to be that screen, and I passed the batch into that screen when I created it. Screen just takes one parameter. The game screen just takes one parameter, the batch, that's it. Just go ahead and pass it in there, and you'll have it, because most of the time you'll never want one sprite batch, right? There's some rare scenarios I can think of where you might want more than one, but in any case, for this project we only want one sprite batch. Cool, and this is how you set up a basic Libgdx project. And now the second class you get when you create a project, so the first class you get is this, the second class you get is this desktop launcher, right? Now if you make a Libgdx build for Android, iOS, and all other stuff, you're going to have a lot more things here. But if you're making it strictly for a desktop application, which is what I normally do with the starter jar that you can download on Libgdx's website. Once again, like I said, if you've never used Libgdx before, I recommend you go to their website, you read some of the documentation. It's really easy to get started with, especially if you already have some experience in programming. But anyways, you get this file, your main game file, that you can name whatever you want, of course. But I've just called it my GDX game, which is default. And then you get the desktop launcher, this file. All I've done here is set it to be 1280 by 720. And I've set it to be resizable false. So cool. And right now we should be doing nothing, because the only other thing I've done is I've added a tile class, which right now only has a render method. All I've done is make a blank constructor and a render method there, which takes a sprite batch. That should be obvious why the sprite batch does the rendering. So it's going to need the sprite batch to do any rendering. And I've also done a tile map. Now this, I've added a render method just like before, blank constructor, and also this fill map method. Now what this is going to do, and you'll see why, I'll explain about this throws IO exception in a moment, but you'll see why that is in a second. But basically this is going to create our map, in a list, and then every frame we're going to render that list to the screen. And as you see, we're actually going to have two lists, and I'll explain why in a minute. So what have I done to the main game screen class? For those of you that don't know, Libgdx works on a system of screens. You have the main game class that extends game, and then that game delegates to a screen, which is going to extend screen adapter to let it know that it's a screen, right? So since it extends screen adapter, it's a screen, so you can use the game class's set screen method. Just call it explicitly. You could also do something ridiculous like this and say this, but you don't have to. You can just call it sort of implicitly like that, explicitly, whatever, and then pass your screen in, the thing that you've made extend screen adapter. Lots of you probably already know this. I just want to be clear about what I've been doing. I also, as you can see, I passed the batch in. I made it equal to this batch up here. This dot batch equals batch, just Java stuff. I made a camera. I set it equal to the size of the screen like we saw here, 1280 by 720. Really simple stuff. I created a new tile map, which as we know right now does absolutely nothing, but you can go ahead and make this class too if you want. It's a very simple class so far. And then here we're clearing the screen to black. In fact, if we run it right now, yeah, it's just a black 1280 by 720 screen. So we're just clearing the screen. That's all these two lines of code do, is they just clear the screen to black every frame so that it can be redrawn. And then you're setting batch.set projection matrix. Now what does this do? Well, basically it tells the sprite batch that you're drawing to the camera. You're no longer just strictly drawing to the screen. You're actually drawing to the camera now. But that's not really important, right? And then I have some camera input keys. So basically, every frame, go ahead and check for these keys, because we want to be able to move the camera around so we can see our entire map, right? And that's all this is. This is how GDX handles, input. Very simple. If the key A is pressed, if the key D is pressed, do this thing. Just change the camera's X position, Y position, or its zoom, right? And I believe this is zoom in currently, actually. But in any case, we probably won't be using zoom today. But anyway, so some basic camera controls. All right, so let's get started. I actually think maybe it might be useful to start in the tile class. Before we make our tile map, we'll go ahead and do the tile class because it's actually going to be really simple. Now, what does a tile need? It needs a texture because it needs some kind of visual representation on the screen. And if you're not sure what a texture is, well, it's actually really simple. It's basically just a 2D image, and you can read the documentation for that. See, it just wraps a standard Open Graphics Library texture, and it gives you some convenience classes, stuff you can do with that texture. For simplicity today, we're just going to use some public variables. We're going to make a public vector2, and we're going to say this is its position in the tile map, and then we're also going to make a public vector2 that is this tile's position in the world pause, or in the world. So when you know what, I'll talk a little bit more about this later. But you have a position in the tile map itself, and then you have a position in the world. And I'll talk a little bit more about that later. So what does this mean? Well, we're going to give it a texture when we create it. When we create this, we're also going to pass its tile map pause position. We're also going to go ahead and pass in its world position, because both of these are going to be calculated in the tile map class, and the tiles are all going to be created in that class too. And then this is just some boilerplate Java stuff. Just some boilerplate Java stuff. I believe anybody watching these videos should probably understand very well what I'm doing here. All right. I don't know why I made that capital, actually. That doesn't need to be capital. That makes a lot more sense. Oh, spelled world position out there for some reason. When I'm trying to talk and code at the same time, it just doesn't really work. Now, all the render method's going to do is just draw this tile to the screen, or not to the screen if it's outside of the screen's view, but it's going to draw it to its position in the world, right? Whether that's on the screen or not. And this is the whole tile class. This is it. Super simple, super straightforward. Now, if we wanted to do something fancy, like have tiles disappear from the screen and reappear as the player walks and stuff like that, we'd have to expand this a little bit like I did in my other video. You know, obviously that tile code's a little bit bigger, but for your basic tile map, this is really the tile class. It just doesn't take a whole lot to do a lot. So let's work on the tile map class. Yep. And you know, our render loop is really simple, right? Update the camera with whatever input was here. By the way, we don't actually have to update the camera every frame. We could take this update and say like, okay, once this, just only call it when we've hit the button, right? And that would probably be more efficient, but we don't really care about little optimizations today. So we're just gonna put camera.update right here. And it's going to be updated every frame regardless of whether we move or not. And then map.render, and that's all we're going to do today. Now, what do we need in our tile map? So I told you we're going to have the base tiles. Now the base tiles are under all other tiles. They always are, so they always need to render under the other tiles. So we're going to have the base tiles, which is the ground, the flat of the map, as you'll see in a moment. We're going to have those in a separate list from things that go on top of it, like trees, mountains, stuff of that nature, that always need to render on top of those base files, right? Also, these being in a separate list is useful because they can be accessed separately to be sorted with a player, and that's outside the scope of this video, but it is useful. Now, why a linked list? If you're unfamiliar as to why I would pick a linked list here, it's because linked list is better in situations where you're going to be deleting or adding to like the sort of middle of a list or something like that. The list resizes very easily, especially upon deleting. And there are times when we would want to delete objects from the list. I'm not so sure that's true of the base, but to keep it consistent, I'm going to put it that way anyways. And like I said, for convenience, we're just going to make these public today. Now, even though they don't actually need to be. So we have our hill texture, and I'm going to talk about the art in just a moment. We have our water texture. We have our grass texture, which apparently is not a texture. Just kidding. But, and we have our tree. That's the tiles we're working with today. We're working with two types of base tiles, which are our grass and our water, and two types of object tiles, which are our hill and our tree. And I'm going to show you that art in just a moment. All right, so let me talk about the art before I move on to something else. So we have the raised grass. This is the water-based tile, the tree. Okay, so let's think about this here. So this is our ground tile. Now, a note on isometric tiles, if you're doing art for them, have some kind of standard size. Don't go crazy with the size. Mine are, this is 32 by 64, and then I've extended it down like 16 pixels or so. And then with the raised grass, what I've done is I've taken the same image, but I've placed it to where it would fit exactly. So they're the same size image, but this one will face is above it. You see how it will sit right on top of it comfortably? That's really great. It's very convenient because I don't have to have an offset, right? As you'll see, I can just put these two at the same sort of world position without needing an offset for this one, because the hill tile already has an offset built into the art itself. And you'll see this works quite well, even when drawing to a specific size, which we will be drawing to a specific size if I'm not mistaken. Let me see here. Whoops, I think Nope, we'll be good. Actually, we're not going to be drawing to a specific size. What we're actually going to be doing, though, is we will be using a size in reference for the world positions. So this is the art, and that's my advice on the art. With the water tile, same. It's basically the ground tile, except it's just blue, right? And you can get a little more fancy through it if you want. Now the tree, what I did was took the image of the raised grass tile. I drew the tree on top of it so it fit nicely in the center, and then I erased the raised ground tile, and boom, I have a tree that when it's drawn to the screen will work quite nicely. So that's my advice on the isometric stuff there. Now let's do the constructor for the tile map. I'm going to copy paste this texture code in. All this is setting the textures, new texture to the files that we have here. And you'll see what the map base.txt is here in a second. This is just to save a little bit of time. And you know, if you think of a different way to do these lists or something, that's all you. Now, we also need to call the fill map function. And we're going to have to do a little bit of try catch with this. I know it's inconvenient to have that code in the constructor, but I would rather have it in the constructor than messing up my method, right? And of course, normally I have like a init method here. So what does our render method look like? It actually looks quite simple. I'm going to copy paste this over too because it's really not. So we're just going to go through each list. We render the base tiles on the bottom. We render the object tiles on top. And that's it. That's the constructor and the render method. Very simple. I don't think anything here should blow anybody's mind. You know, basic exception catching. And you'll see why we need that in a moment. You know, basic rendering, going through the list with a for each, rendering each one, and making sure they're under the objects. Really basic stuff. I don't think this should be blowing anybody's mind. Cool, so you're just initializing everything. Now here's where the magic's going to happen. So, what do we need here? Well, I'm going to generate, this is cool. So instead of just randomly generating the map, I'm going to generate it based off of a text file. So I've said that the base of my map is going to be generated off of a text file. I'm going to actually randomly generate the trees for ease because I didn't feel like making a second text file and loading it in, but in any case, so the G's are going to represent where ground's going to be, the W is going to represent where water's going to be, and I could change this any way I wanted, but I'm happy with it the way it is. And they're just separated by one space, and that's it. You can make this as big as you want. You can make it as small as you want. Totally up to you. Now, it's good to have a known size, and my known size is going to be 10. So what do we need for this? Well, this is what we're going to load the file into. We're going to load it into a string two-dimensional array. And like I said, mine's going to be 10 by 10. So just like I showed on the text file, 10 across by 10 down. And then from that text, from this array, we're going to make sort of our map. Now, in Libgdx, accessing files or text files over here, accessing textures is really easy. Accessing text files is a little bit more annoying, even if they're in the assets folder. So how are we going to do that? Well, we're going to use something that Libgdx calls a file handle. This is a Libgdx specific type of thing. And with it, we're going to access our internal files. Don't worry about what that means. If you want to, you can look at the documentation. But basically, we're going to access this file in our assets folder. Oh, whoops. Just like we do a texture. Base.txt. Okay, and then we're going to use that file handle to do some basic input-output in Java. If you've never used a buffered reader before, or you don't know much about input-output, you know, I recommend just kind of Googling I/O in Java, and you'll find a nice little explanation of how to use buffered reader there. And this is how you use it with text files in Libgdx. So that's kind of what I'm showing y'all today. And it may not be the best way to do it, to generate a map, but I think it's still useful to know. So it's something I'm going to show you how to do. Now, let's just set this to some blank value rather than null. I'm making a string because that's what we're going to read each line of the file into. Whoops. I'm making a count variable sort of because we need to know where to put each line. It'll make more sense once I start the. Okay, so this is going to be some basic file input output. So we're going to say that buffered reader. And if you're wondering why I'm using a buffered reader as opposed to a scanner or something like that, well, no particular reason. I just kind of like buffered reader. But we're just going to, and if you're confused by what a buffered reader is, it's just a reader that's a little bit more, a buffered reader is just more efficient than a reader. Like a regular reader is just like a class that reads text files without buffering them, but a buffered reader makes it a little bit more efficient. If you want to know why that is, just Google it. There's plenty of better explanations than I would give. But anyways, it's really easy to use a buffered reader. Basically, we're going to say while the buffered reader has lines, while it doesn't return null into S, go ahead and read that line into S. So we're going to get the file line by line. Now this is the interesting part. We're going to go ahead and we could probably use a for loop here instead of a while, but I kind of like the while. And then we wouldn't need the count variable, but I just kind of like the while. Anyways, and this is cool. Since we're looking, we have an array of arrays, right? We have 10 arrays in this two-dimensional array, because that's what a two-dimensional array is. You have an array of arrays, and each one of these lines is going to represent an array in this two-dimensional array, right? So you have 10 arrays in this two-dimensional array, and each line of the map is going to represent one. Cool. And I'm not going to worry about checking to see, and we're going to split that by space because we know in my text file I split the letters by space. Cool. So this is done. Oh, a note about this. Basically, let's see. Why is it telling me? Oh, I have to close it. Oh, okay. I thought it was telling me I didn't use it. I was like, I absolutely used it. Anyways, so in order to get the path to this text file, you need to use a file handle. Unfortunately, with Libgdx, you cannot just put this path into here and the file reader will be able to find it. Even if you were to get its absolute path in the folder, I think it still would not work. So you have to use this file handle. But really, it's not that bad because it's only one extra line of code. And hell, you could you could actually shove this line of code in here. I just didn't because it's like messy. Cool. So we've loaded our map into this array of arrays. Now, I mean, if you really wanted to see what that looks like, we could just do a quick system.out print line, and you could say like, okay, go ahead and print each line. So before you split it and put it as an array, if you've never used split before, really simple. It's just going to say like, okay, every character, basically turn this string into an array based on this delimiter. So if, you know, it's a G and then a space, it's going to become G, and then the next letter, the space is going to get removed. G will be at position 0 in the array, etc. Let's see. Hopefully I don't crash anything. Okay, so you can see my text file is neatly printed out here in the console. So there you go. That's all we're doing. We're taking each row and we're making into an array. This G is at the 0 position. This G is at the 9th position. And each one of these is an array. in this array of arrays. Really easy. Really, really easy. I feel like that should not be blowing anyone's mind. We are going to make a random. This is just the Java random class that will generate random numbers for us. We're going to make that because we are going to have our trees and stuff be randomized. We're just not going to have the base of the map be randomized. And you can do as much or as little randomization as you like. What we're not going to do in this video is write some kind of complicated, algorithm for generating a map. But we are going to generate one from a text file, which I feel is at least as useful, maybe. And this is the same code that we've done in my old tile map videos. So all this code is doing is going to loop through, essentially loop through the two-dimensional array backwards. I feel like this shouldn't be blowing anyone's mind either because it's just a typical looping through an array. Now, the math might blow someone's mind, but I suggest you just get to thinking about it. Now, the math here. This is the same math we've used in other videos. Now, why the 0.0001? I played with the numbers a little bit and found that that works best for me lining up the tiles. But basically, this determines your tile's world position. Your tile's tile map position is going to be the row and the column. So say this is tile 0, 1, it's going to end up having a world position that is negative, right? Because it's going to be -1 here. Its x position is going to be negative. So you can, I would suggest thinking about this math and how it translates into a world position. Now what this represents is your tile width. This represents your tile height, which is associated with the y, and width is obviously associated with the x. So that's all this is. This is tile width, tile height, and like I told you before, 64 by 32 is what I was using. And then it's divided by 2 because that sets it into position correctly. These numbers over here are really what determine how far they are apart from each other on the x and how far apart they are from each other on the y. So if you want separation between the tiles lengthways, then go ahead and increase this number. If you want separation between the tiles heightways, go ahead or increase this number, or decrease it maybe depending. But in any case, these are the numbers I've found work for me. Now, we need to go ahead and check. Now, the reason why this is 9, by the way, is because our array is 10 by 10. This is what I've found works. So we don't want to go out of bounds in our array, correct? But what we do want to do, we want to go ahead and say, like, okay, at this position in the tile map, or at this position in the array, which is a string now, because we know that it's a string array. It's a string array of string arrays. It's a two-dimensional string array of string arrays, right? So we know that this is a string object we're getting at this particular position in the string array. And we're going to use dot equals to check, because that's how you should check equality with strings, if it's G. If it is G, then we're going to go ahead and say, well, and I'm going to copy this in, by the way, because it is not mind-blowing at all. We're going to say, go ahead and put a base tile there. And for that, we're going to add, so we know this is a list of tiles. We're going to add a new tile. You can just put it right into the sort of add statement there, or you could make it outside of the add statement and then just stick it in there. Now, as we know, our tile needs a texture, a tile map position, which is the row and column. So for example, the first one will be 9, 9, and then its world position, which is calculated here. And like I said, go ahead and give this math a good think, and I think you'll figure out that it's not too hard to think about world position and stuff. Now, if in fact it equals W, and you could make this as complicated. You could have as many different types of tiles if you wanted, right? You could have one that's like, you know, I don't know. You could have one that's just a B for blank, right? And then it's just a hole in the ground or whatever. Now what we're going to do here, we're going to add a water tile with the water texture, and the same deal. Tile map position, world position. Now let's see here. Why? Okay. Let's see here. That should be enough to get us started, actually. We don't even need to use the random yet, I think. Yeah, and there we go. Our map is generated to the screen. Now, I'm going to think about a few things here. So, if you're really smart, you can tell that it's a little bit backwards. The map has been flipped a bit. So this side here is equivalent to this side here. This side here is this side here. So the map actually gets flipped due to us going through the array backwards, I believe, and also due to the isometric projection. But this is cool, right? We had our map in the text file, and we've generated our map. And it exists, right? We have our camera controls. We can move around. Boom, that easy. We already have the base of our map, and it can be any size. It can have any kind of tiles in here and look like however we want. You could make the tiles bigger or smaller. We'll go ahead and add some trees in here to make sure that that works. I'm going to copy paste this in, I'm sorry, and then I'm going to explain it. Okay, so this number is going to be gotten from the random. We're just going to say give us an int between 0 and 100. So there's roughly like a 30% chance of there being a tree, whereas there's only a 3%. There's only like a 3% chance of there being a hill. But let's say that there's now a 10% chance, so we can get some hills in here. And this is the same project, same procedure, except you're adding it to the objects tile now. So once we do that, we should be basically good. Let's see how it comes out. Okay, so look at this. Now you could have a totally different map, a totally different text file for the objects map. I've just done it randomly, so it'll be different every time I load it, but this is cool, right? Everything renders correctly. This hill is on top of this tree, but it's behind this tree, and everything renders correctly naturally using this method. And we have we have some height here. It looks like real height. It looks like we really do have some 3D going on here. And our base map is still as it was. I made sure nothing gets drawn on the water tiles because I only draw a tree or a hill on top of grass tiles, right? At the position of grass tiles, at the world position of grass tiles. Now, before I end this video, let me talk just a little bit more about world position. So the tile position, say, of this tile, say it's 0, say this tile is 0, 0, that's its tile map position. But its world position from the bottom left corner of its texture could be any number of things. And you could figure this out by going through each tile and having them print out their world position. I don't think that's necessary today, but just remember it has a tile map position and it has a world position that's totally separate from that. And if you wanted to have a player jump up on this tile, you could play a little animation, and then while the player's on this tile, he would just need an offset, right? And boom, that's it. He has a little offset, and then you've achieved some sort of 3D here. We're not doing a player today because I'm already at 35 minutes of video. But anyways, I know that I gave a long-winded explanation today, but I think that this can be useful to somebody. Let me know what you think and have a little bit of fun with this. Create your own text files and see what kind of map you can make. Maybe make your own objects. And if you want to know a little bit more about how I did the art, you can ask me or whatever. Like I said, with isometric stuff, the art has to be correct. You can't just willy-nilly make things all kinds of weird random sizes. You really have to get the size correct. Or you really have to think about the sizes of everything and be consistent, so that way it all renders nicely. So for the heck of it, let's load it up one more time and see what kind of random stuff we get. Very cool. We got like an absolute nest of forest of hills and trees over here. But anyways, that's the video for today. Let me know what you think. And also, if there's something else you would like me to do with this, let me know. And like I said, once again, you could have borderless tiles. Just make the coloration not have a border, right? But I thought about, I know that so far I've been making a game with like tile-based movement. I thought about actually just going full old school RPG and like maybe making a tutorial series on like making an old Diablo game or something where the player can just kind of like move around completely willy-nilly. That'd be a really big project though. But anyways, let me know what y'all think about this. I think it's pretty cool.